Okay.
Let's see now. Refresh is Shift F5. Um, I'm just going to close the app and okay. So can you see the screen? You can't. No?
No, I can't.
Okay, let me reshare. Okay, so I believe now you can see the screen. All right. So we were explaining the electrostatic force at this specific point, right? So it is described as the electrostatic force experienced experienced um, a unit of positive charge placed at the point. Okay. Now for 7.2, let's go read the question. Now they want us to calculate the net electric field at point P. Calculate the net electric field at point P. So looking at the information here, the net electric field that is going to be at point P, which is this one. Um, this will impose a force there. Also, this will impose a force there. But now the issue is the net electric field here must be the combination of the two forces. That will be the net electric field there. But now this is positive, this is negative. Even if you add them, they're going to subtract each other because of the nature of their charges. Okay? So therefore, the net electric field at point P will be calculated as um, so E net, let me start like this, is equals to electric field at point A minus electric field at point B. Or let me just say plus, because this is the standard formula. Okay, then it will be the net electric field. Now it's going to be K Q charge A minus R squared plus K charge B minus R squared. Now when we substitute, because of the signs, it's going to be 9 times 10 exponent 9. That is K multiplied by charge of A. Now, charge of A, they said it's 6, and the other one is minus 3. So we are going to have this times 6 times 10 power minus 6, and then divided by the distance squared. So the distance they said it's 3 plus 1. 3 plus 1. So it's 4. It's 4. So into 4 squared, then plus 9 times 10 exponent 9 times minus 3 times 10 to the power of minus 6 over 1 squared. But now, in electrostatic forces, we don't put these negatives on the formula. I just wanted to correct this, right? So instead, from the word go, we are going to write it here, right? Even here, we are going to write it as a negative. So basically, this is going to be there. Then this will remain as positive. So the main reason I wrote it like this, I want you to understand that they always add net electric. This is P. So the net electrostatic forces at a point they add one another, right? So the negative that you are going to see here, it's not because of something miraculous. It is derived from this negative up there, right? So just wanted you to see that point. So now the correct substitution will be a positive 3 times 10 to the minus 6, like that. So now we need to press this on a calculator. Where's my calculator? Okay. So it's going to be 9 multiplied by 10 exponent of 9 times 6, okay, times 10 exponent minus 6, everything divided by 4 squared, minus fraction 9 times 10 exponent of 9, 9, okay, times 3 times 10 exponent minus 6 over 1. Okay, now I get the answer as a negative 23, 625. So because of it is a force, it will be newtons per coulomb. So electrostatic force, electrostatic field at the point. So this will be the units for the net electric field at a point. So now, are you fine? Okay. 7.3. A proton is placed at point P. Remember, a proton is a positively charged particles from chemistry. Okay. Now, since a proton is placed at point P, calculate the magnitude of the initial acceleration of a proton if the mass of the proton is 1.67 times 10 to the power of minus 27. So they want the net acceleration, right? So now they are trying to mix this with Newton's laws. Now let's see what we are going to do. We will come back to the mass. At first glance, the mass doesn't work, right? So we need a specific formula. I just want to show you the formula sheet so that you see which formula I will be using. So this is page 21, print. Okay. so that even for the next questions it becomes easy for us. Okay, now the useful equation under these circumstances will be this one over here, the circled one, right? Why? Because we have got net electric field at point P, and then we've got that we know the charge of a particle of a proton. It is a constant, right? It is a constant, so then we can work around that. So, what else do we need to know? Um, okay. Also, let me give you a list of constants so that you don't get surprised about where do you take this charge. What line? Also, what? Okay. So for IB, the constant will be slightly different. Ne? Oh, and by the way, the main reason. So I'm going to give you a hint here. When I'm giving you tests, I'm giving you based on IEB, right? So when we practice, we are practicing using the caps one because IEB papers are too few, right? So that when I give you test, I want to give you the ones from IEB. We're just gonna practice using the caps one. The questions are more or less the same. So please don't be offended when I'm using this ones the most. Okay.
Okay.
I just don't want to finish the other ones the other side. So that's why. Okay. Now, all right. Now that we have constants, we can go back. So now we are going to use this formula that I circled, right, to calculate a charge. So now it's 7.3. The formula that we chose to use is E is equals to force divided by a charge. So the net electrostatic field, we got it to be this value. Okay, so that is the value that we want. Now, when we write this value, we are only going to take it as a positive value. Why? That negative only tells us the direction where the electric field was going to, right? So we are not going to pay attention into the sign. Hence, even up there, I was correcting something to say, no, no, the sign will be there. Don't be surprised why we don't write a negative value there, right? Now, divided by the charge will be 1.6 times 10 to the power of minus 19. Okay, so where do I take the charge? So this is the charge that I took. So electrons and protons, they have similar charge. So this is the charge. The difference is that electrons are negative and protons are positive. Do you see why I take the charge? Okay. Then we can calculate for the force. So, oops, like now the force F will be equals to 23,625 multiplied by 1.6 times 10 to the power of minus 19. So force will be equals to, let's check, I got 4.48, okay, times 10 to the power of minus 15. Let me do it again. 23,625 times 1.6, right, times 10 exponent minus 19. Hey man, why is it different now? 3.78. You please do it also from your side. Am I getting
I got 3.78.
okay? So my first calculation also 3.78 times 10 to the power of minus 15. So since this is a force, it's gonna be in newtons. But the question wanted acceleration, right? So since the question wanted the magnitude of the acceleration, so now we are going to use the formula of F net equals to ma. Alright, then we substitute our 3.78 times 10 to the power of minus 15 equals to mass. So mass of the particle, let's go to the mass and see. Let's go to the mass and see. Oh, they gave us the mass on the question. I'm sorry. This is the mass they gave us. 1.67 times 10 to the power of minus 27. So we substitute the mass as 1.67 times 10 to the power of minus 27 multiplied by A. And we are looking for A. So what do? We divide by 1.67 times 10 to the power of minus 27. Even this side, you divide by 1.67 times 10 to the power of minus 27. So these two, they cancel each other. Now A will be equals to, let's see, 1.67 times 10 exponent minus 27. Now A is equals to 2, comma 26 times 10 to the power 12. Okay, now since it's acceleration, the unit must be meters per second squared. Nearly forgot. Okay, now question 7.4. If an electron was placed at point P instead of a proton, how will the acceleration of the electron compare to that of the proton? Okay, now based on this formula sheet, right, I want you to notice something. Look at the mass of the electron. Can you see the mass?
Mm-hmm.
The mass is 9.11 times 10 to the power of minus 31. But the mass of a proton, it is 1.67 times 10 power minus 27. So minus 31 is smaller than minus 27, right? So the electron weighs less compared to a proton. So we are going to answer with reference to this. That our question number 7.4, it will have a larger acceleration because we are talking about the electron. Why does the electron has a large acceleration? because mass of electron is smaller than mass of proton. And then we know that acceleration is inversely proportional to the mass. So the smaller the mass, the bigger the acceleration. So electrons will have a larger acceleration as a result. So this is where the question would end. So let me get another question. Or before I get another question, do you have your own question based on this?
Mm-mm, I don't.
Okay, let me come with another one. Feel like DJ Khaled. Hmm. Okay. You can read the question for now. Then I will start solving. Okay. It's important that you also understand what is required of us. When you think you understand it well enough, um, you can tell me, then I can solve. Okay. Or you want
Okay.
to attempt it first, whichever that you prefer. I wouldn't mind to solve it.
I think you can attempt it.
You think you can?
You can do it. I mean,
Okay, I can do it now.
hmm
Okay, no problem. Um, Let me repeat, then we begin. Okay, now a metal sphere X with a charge of positive 5 nanocoulomb, nanocoulomb is times 10 exponent minus 9, is suspended by an inelastic thread of negligible mass which is tied to the ceiling at point M. Another metal sphere Y on an insulated stand is tied up another metal sphere Y on an insulated stand has a charge of -8.9 nanocoulomb and is brought closer to sphere X until their centers are 20 millimeters apart. So just to emphasize on the numbers, 5 times 10 exponent minus 9, minus 8 times 10 exponent minus 9, and 20 times 10 exponent minus 3. So those are the meanings of nano and milli. Okay, now state Coulomb's law in words. Okay, is it question 7? Yes. So the magnitude of the electrostatic force exerted by one point charge on another point charge is directly proportional oops directly proportional, yes, to the product of their magnitudes of the charges. Okay, and inversely proportional to the square distance in between them. Okay, so this is one of the longest definitions you can write in physical science. So you will see how you, but don't shorten it at the expense of information. Um, Now calculate the magnitude of the electrostatic force. That's sphere Y, the one on the right, exerts on sphere X. Okay. Um, so calculate the magnitude of the electrostatic force. So the fact that they asked about Coulomb's law, we are going to use the equation that defines Coulomb's law. All right. So 7.2, the equation that talks about Coulomb's law is F equals to K Q1 times Q2 divided by the squared distance in between them. Okay. Which is R squared. Now calculate the magnitude of electrostatic force. So we've got both the charges. So it's going to be 9 times 10 exponent 9, 5 times 10 exponent minus 9, then we've got 8 times 10 exponent minus 9. Please bear in mind that I did not put the sign for the 8 nanocoulomb. I left it as positive, even though it is negative in actual fact. It is not a mistake, okay?
Okay.
Oh, you see, this topic is going to finish the buttons of my calculator. So it's 9 times 10 exponent 9 into 5 times 10 exponent minus 9, then 8, 8 times 10 exponent minus 9, divided by 0. I said 20 was 20 milli, so it's gonna be 0.02 squared. Okay. Uh, Now the answer that I'm getting, it's 9 times 10 exponent minus 4 newtons. That is the force.
Okay.
Now, 7.3, draw the, draw the resultant electric field pattern produced by spheres X and Y. Mhm. Okay, so here they just want to see if you understand electric field patterns. So 7.3. Um, Now I'm going to say this is my sphere X, then this is my sphere Y. So sphere X, since it's positive, um, they're going to go out of sphere X. Okay. Now sphere Y, they're going to enter since it's negative. The lines must never cross each other. They must be in a way that they are parallel to one another. So it is going to be something like this. Okay. 7.4, sphere Y is now moved closer and makes contact with sphere X, after which sphere X is repelled. Calculate the new charge on the sphere X. Okay. So now, because of the charged, the charges touched one another. You know what's gonna happen? They now share the charges with one another. So they're going to have equal charges. So how do they acquire equal charges? So let me show you on paper now. For question 7.4. So we're going to say Q of the new charge is going to be Q1 plus Q2 you divide by 2. which is going to be 5 times 10 exponent minus 9 um, plus. Now that I want to know the actual charges, this is the only time we are going to put the negative charge. So this, I'm just going to put it as it is because we want to know what is the new charge after they combine. So it matters which one is positive, which one is negative. So after doing this, 5 minus 8 is going to be minus 3 times 10 minus 9 divided by 2. Now this looks like it's going to be minus 1.5 times 10 exponent minus 9 or minus 1.5 nano coulombs. So you choose which one you want to write. That will be the Q new. Happiness.
Mm-hmm.
Oh,
Yes.
great. Um, let's see. Ah, it's all of them. Okay, you see, no problems. We can just also find a new question to do. These questions they're very easy, you see.
Mm-hmm.
Okay, now let's see if you do understand. The one I'm giving you now, you are going to write it by yourself. So don't be surprised. Um, okay, we can start here. See?
So I'm a bit confused on how to find the number three.
Number three. Mm, I see. Um, Calculate the magnitude of charge Q. Okay, just give me a second to read the instructions. The centimeter white line. Okay. So the 2 point charges Q1 minus 3 times 10 minus 9. Okay. So do you want me to advise you or you want the answer? Which one?
I'm you can advise, I guess. You can advise.
Okay. Now, uh, you stated giving reasons you defined. Now you need to calculate the magnitude of charge Q. Um, The formula that you're going to use, it is E equals to KQ divided by R squared. Why? Because we are talking about electric field, not electrostatic force, but electric field at a point. Now, how are you going to solve this electric field? Now, the instruction says 2 point charges Q1 and Q2 are placed 30 centimeters apart along a straight line. Now, Q1, that is the value in coulombs. Now, point P is 10 centimeters to the left of Q1, as shown in the diagram below. Now, the net electrostatic field at point P is 0. So we do know the net electrostatic field at P that it's 0. All right. So um, so what does this mean? It means that electrostatic field at Q2 plus electrostatic field at Q1 is equals to 0 with reference to P. So that's what it means. Then you start to solve for the value of Q2 from there.
Okay, I see.
Okay, just try it out. If maybe this giving you problems, then I will do it for you. So How far?
I'm on 5. Can you please move down? Okay, I'm done.
Okay. I'm curious with your answer in 7.3. What is your final answer?
7.3. Um, I didn't put a unit, but it's minus 2,700 coulomb. Is it?
Okay. No. I'll have to do this one for you. Um. Okay. Let me do this one for you. Let me just
Oh
do.
no, I didn't say my final one. I made a mistake. I looked at the wrong. Is it 4,8 times 10 to the power minus
Yes.
8
Yes.
coulombs? I looked at the previous step.
Okay. That's great. Yes. And state Coulomb's law. Okay. Calculate the magnitude of the 7.5. What is your answer?
1,444 times 10 to the power minus 5
Okay.
newtons.
Great. I think I'm happy with those answers. Yeah, I think I'm going to end the session here then.
Okay,
Yes, thank you. Sharp, sharp,
bye.
bye bye.